This lesson is on comparing slopes and the meaning of a slope. Paul compared the slope of the function shown below to that of a linear function with an x-intercept of a 4 and a y-intercept of -2. What is the slope of the function with the smaller slope? So we have two different lines going on here. We have the one shown below, which is the black line, and we want to compare that to a line that has an x-intercept of 4 and a y-intercept of -2. So we need to draw this line so that we can compare the slopes. So x-intercept of 4, now we haven't dealt with x-intercepts before. X-intercept of 4 is just like a y-intercept except it's on the x-axis. So on your x-axis, go to 4 and put a dot. He has a y-intercept of -2. Well, you go on your y-axis to -2 and you put a dot. And then you draw your line. Now, we haven't talked about the slope of either one of these lines, but the first thing you have to do is establish both of your lines. The question says, what is the slope of the function with a smaller slope? Well, when we talked about slope, we talked about steepness. If you have a line that's really steep, it has a bigger slope than if something is less steep. So if I want the smaller slope, I want less steep. So which of these two lines has a smaller slope? Which one is less steep, the black line or the blue line? And the answer is the blue line. If you were hiking this, the blue line would be less steep. So the blue line is the winner. But I need to know what the slope of the blue line is since he's the winner. Well, I have my 2 points, so now all I have to do is count up to right 4. And that reduces to a 1/2. Paul compared the slope of the function shown below, so that's the black line, to that of a linear function with an x-intercept of 4 and a y-intercept of -8. So x-intercept of 4, x-axis, put a dot at 4, a y-intercept of -8, so go way down here to -8, and then draw your line. What is the slope of the function with a smaller slope? So which one is less steep, the black line or the blue line? And the answer is the black line. So the black line wins this time. So I need his slope. Now he doesn't have any dots on him, so we have to figure out what his dots are. I like this one. And really, I mean, it looks, I like these. So if we were to count this, this would go up 1, right 1, up 1, right 1. So his slope is 1/1, which is D. A and B are not an option because both of these lines increase. They both go up. So your only choices are really C and D. So look at the line you were given. Draw the line that they give you information about. If they want smaller, you want less steep. If they want bigger, then you want the most steep. Figure out which one's the winner, and then find the slope of the winning line. All right, changing gears. The cost of a large pizza is given by the formula C of t equals 1.5t plus 7.50, where C of t is the cost of the pizza and t is the number of toppings. So C of t is the cost, how much it's going to cost, and t is the number of toppings. What does the slope, and this is the word I want you to box in, what does the slope represent? Well, which one of these numbers is the slope? And the answer is 1.5. We've kind of been talking about this all along. This is your starting value. So what does this represent? Well, this is a pizza with no toppings on it. This is your base model pizza. And then for every topping, what's going to happen to the price? It's going to increase $1.50 per topping. So what does the slope represent? Does it represent the number of toppings? No, that's T. T represents the number of toppings. Is it the total cost per slice? No, that's C of t. That's the whole thing. Does my slope represent the cost of each topping? Yes. The cost of a pizza with no toppings. Now, what would D B. D is the 750. That's your y-intercept, the cost of a pizza with no toppings on it. This is your starting value, and that's how much you're increasing each time you add a topping. So the slope, which is the 1.5, represents the cost of each topping, how much it's going to add to my total cost. The equation y equals 461.19x plus 3,492 represents the value of a work of art from 1964 to 2005. What does the number $461.19 represent? Okay, let's just look at this equation before we go read our answers. This represents a work of art from 1964 to 05. So what is this number? That is its value in 1964. That is its starting value. What is this number? That's how much it's increasing in value every year. And it says, what does this number represent? So I need to find something that says how much it's increasing in value. So A says the value of the work of art in 1964. No, that is that number right there. The value of the work of art in 2005. No, I don't know what that is. Yearly decrease in value. Well, that's close, but is the value of this work of art decreasing? And the answer is no, because my slope is positive. Yearly increase in value, yes. The boiling point of water, T, measured in degrees at an altitude A, measured in feet, is modeled by the function T of A equals negative 0.0018 A plus 212. In terms of altitude and temperature, which statement describes the meaning of the slope? Well, this is my slope. First of all, let's notice that it's negative. So we should say something about decreasing or going down. This is the boiling point increases. Not true. The boiling point increases. Not true. The boiling point decreases. Boiling point decreases. I like both of those. But then look at what they've done here. They've made this just a little bit tricky. It says 18 degrees per 1,000 feet. And this one says 1.8 degrees per 1,000 feet. Well, we have 0.0018. So how do we know if that's 18 per 1,000 or 1.8 per 1,000? Well, if you'll take your calculator, give me just a second. If you'll take your calculator and let's see, we'll do this one first. 18 per 1,000. So if I go 18 divided by 1,000, the goal is to get this number that's circled in the problem, the 0.0018. And does that work? No, I'm a 0 off. So if we try D and go 1.8 per 1,000, there we go. That's the right number. Decreasing and it's negative, so that's good. So we're going to go with D. So that one's a little tricky. They threw you a little curveball, but nothing the calculator can't help you with. The table below shows the amount of cars having been through the gas station for the hours it is open. So if it's been open 3 hours, they've had 60 cars. If it's been open for 6 hours, they've had 120 cars. If it's been open for 15 hours, they've had 300 cars. It says, what is the meaning of the slope? Okay, now I've got a way to do this, and it will work every single time. If you will do it this way, you will never, ever miss these. If you try to just kind of wing it, you're going to get something mixed up, and you're going to pick the wrong answer. And these are really not difficult. So this is not one you want to miss. Okay, you know that slope is y minus y over x minus x. When you have a table, these are your x's and these are your y's. I always want you to label those. So I'm going to pick 2 points. And I'm going to go y minus y. So I'm going 60 minus 120 over 3 minus 6. That gives me a negative 60 over a negative 3, which reduces to a 20. I'm going to put my 20 over 1 because I'm getting ready to break this down. Okay, remember, slope is y's, so these are y's, over x's. So here's your x. So something about 1 and something about a 20. Well, if you look at A and B and D, they all talk about a 20 and a 1. So that's not the important part. The important part is how you break it down after this. This is the most important part. Look back at your graph, your chart. What do y's represent in this problem? And the answer is cars. So I want you to come over here and put cars. And then x's are the hours open. So now it's really easy because we can say for every 1 hour open, 20 more cars go through. So let's see if we can find that. The gas station's open for 20 hours. Nope, 20 is cars. Gas station serves 1 car every 20 minutes. Nope, these aren't minutes, these are hours. Gas station serves 60 cars per hour. No. Gas station serves 20 cars per hour. 1 hour, 20 cars. Yes. So find your slope just like we've done when I taught you slope. But the most important part is this part. Putting it over 1, labeling it y and x, and then writing what they are. And then it's 1 hour, 20 cars. Super easy if you break it down at the end. Okay, let's try another one. Shanna is saving her money from her summer job. So she has days and then she has her earnings. What is the meaning of the slope? Okay, so we're going to find the slope. So we're going to go y minus y over x minus x. I'm going to pick the first 2 points. So y minus y over x minus x. So that's a negative 40 over a negative 2, which is 20. I'm going to take that 20, I'm going to put it over 1. And this is the most important part. Now I'm going to break it down. That's a y, and that's an x. Because for my slope, my y's are on top. In my chart, those are my x's and those are my y's. So y is earnings. So I'm going to write earnings. And then this is days. Now before we go read, let's figure this out. 1 day, $20 in earnings. 1 day, $20 in earnings. Shanna earns $40 per day. No. Shanna earns $1 every 20 days. Well, it has the right numbers, but it's not the right stuff. It's 1 day, $20. Shanna earns $60 every 2 days. No. Shanna earns $20 per day. Yes. The function below shows the cost of a hamburger with a different number of toppings. What is the meaning of the y-intercept? Okay, so they've changed it up a little bit. Before they were asking what is the meaning of the slope. This one wants the meaning of the y-intercept. All right, and then they're trying to be sneaky. Look at this function. What have they done? They have flip-flopped the y-intercept and the slope. Normally, it's y equals mx plus b, where the slope and the x come first. Their slope and their variable are now second. This guy is your y-intercept. We know that because the y-intercept does not sit with the x, or the t in this case. So the y-intercept is 1.9. It shows the cost of a hamburger with different number of toppings. So the 1.9, your y-intercept, doesn't have anything to do with toppings. That's your starting value. So that's your base hamburger. So it's not $1.40 per topping. It costs $1.90 for a hamburger with 0 toppings. I like that. It costs $3.30. No. It costs $1.90 per topping. No. If it's a per, that's slope. This $1.90 is just for a hamburger with no toppings on it. Table below shows the amount of shoes purchased at Shoes Unlimited. Hours open, pairs of shoes. What is the meaning of the slope? Do not look at your answers. Go find your slope. These are x's, these are y's. Y minus y over x minus x. Negative 30 over negative 2, which is 15. Now this is the most important part. You got to break it down. 15 over 1, y's over x's. What are your y's? Shoes. What are your x's? Hours. 15 shoes per 1 hour. 30 pairs of shoes per hour? No. 15 pairs of shoes every hour? I like that one. 15 pairs of shoes every 2 hours? No. 1 pair of shoe every 15 hours? No. Gotta be B. Again, the most important part.